Hello everyone, welcome back to CloudOps Craft. Today we are going to discuss about Docker, like introduction to Docker and why architecture matters. Okay, so the thing is, let's start with a simple question. When you say you are running Docker, what's really happening behind the scene? Most developers think Docker is just about typing Docker run in the terminal and suddenly having a container. But behind that simplicity, there is a very well designed architecture. Docker is like a restaurant. You consider you the customer, place an order, that's your Docker command. The waiter, which is Docker client, takes your request. The kitchen staff, which is Docker D, prepares your meal using integrants, which is image. Finally, the dish is served, which is a running container. Without understanding this process, you are just eating the food without knowing how the kitchen works. Today we will go deep into the kitchen. Okay, so like the thing is, the flow will be Docker, like you. Okay, you will contact. Well, let me zoom this. You will you will contact Docker client. Client will contact Docker D. Docker D creates images. From the images, we are running the containers. This is the flow, right? So let me explain. So if Docker is the restaurant, what could be the equivalent of a recipe book, which is Dockerfile? Okay, let's discuss about Docker client. Docker client. The thing is, Docker client is your main entry point into Docker. Whenever you type a command like docker run nginx, for example, you are actually speaking to the Docker client, which then translates your request into an API call. The client does not directly create containers. Instead, it communicates with Docker D over REST APIs. Think of the Docker client as your food delivery app. You don't cook, you just send an order. Okay, here while coming to type of clients, there are three type of Docker clients out there. One is Docker CLI. Okay, the terminal command tool. Okay, you can run Docker PS, etc. Second is Docker API, a REST API that allows automation tools to communicate with the Docker. Third is Docker Desktop, a GUI based client for Windows and Mac users. Okay, so whenever you type a command, okay, so the flow will be, whenever you type a command, it will go to Docker CLI, like in Docker CLI, Docker CLI to Docker REST API, REST API to Docker D. Okay, so what happens if you run a Docker command on your laptop, but the Docker D is running on a remote server? Just pause the video and let me know if you have answers. The thing is, the client is just forwards the request. The Docker D does not have to be local. Okay. Next is Docker D. Docker D. Actually, Docker D is the real workhorse. It listens for commands from the client. It manages Docker objects like images, containers, volumes, and network. It ensures containers are running and isolated. For example, Docker D is the chef in the restaurant kitchen. Okay, the waiter, which is our Docker client, does not cook. They just pause the order. The chef, which is Docker D, knows where the integrants, which is images, and how to prepare them, and finally serves the meal, which is our container. Docker D can also talk with other uh, others to manage containers across us multiple servers. That's how Docker Swarm or Kubernetes node work. Okay, so the major responsibilities of Docker is listen for the request, manage images, create containers, handle networking, manage volumes, communicate with other uh, daemons. Okay, so what do you think the Docker client and Docker D are separated instead of being one single program? If you know the answer, just pause the video and let me know on the comment section. The major reason is flexibility, security, and remote communication. Okay, so now let's discuss about Docker objects. Okay, to understand Docker architecture fully, you must know the key Docker objects. First is images. Think of them as a blueprints or recipes. Immutable, they don't change once built. Okay, and images are built using Dockerfiles. Okay, so second is containers. It is a running instance of an image. They add a writable layer on the top of the image, lightweight and isolated. Okay, third is volumes. Persistent storage managed by Docker. Without volumes, data vanishes when a container stops. It's like a notebook where you keep your recipes, even if the chef changes, the notebook stays. Fourth is networks. Any idea on networks in Docker? If you have any idea, just let me know in the comment section. The thing is, networks, what is the purpose of networks here? The thing is, it will allow containers to communicate. Docker provides bridge, host, and overlay networks. It's like a restaurant delivery system where whether dine-in, pickup, or delivery networking makes the meal reach you. Okay, so while coming to Docker objects, images, which is the content, with the help of images only we will create the containers. Volumes, which is for persistent data. Networks for container communication. Okay, so how they work together? So now we need to learn the life cycle walkthrough. Okay, let's tie it all together with a real life cycle. Okay, when I type docker run nginx, okay, when I type docker run nginx, the Docker client checks if the image is available locally. If not, Dockerd pulls it from Docker. Dockerd creates a container from that image. Networking and volumes are created. Container starts and access it. Okay, so the flow will be Docker run nginx to client. It will go to client. From client to Docker D. Okay, from Docker D, it will check the image. If no, it will pull from hub. Okay, and it will create container, and after that we will configure network and volume, and we'll start the container. Okay, here you can ask one question, like since it's a recorded video, so I'll ask, okay, why does Docker need to layers images instead of storing a whole new copy each time? The thing is, the major reason is efficiency. Shared layers saves disk space. Okay, so this is all about this architecture. In next class, like in next video, we will create your first Docker container. We will set up Docker and we will create your first Docker container. Okay, if you like this breakdown, subscribe to CloudOps Craft. We will simplify cloud and DevOps concepts every week. Thank you. Hello everyone, Welcome back to CloudOpsCraft. In our previous session, we learned how Docker works, the client, Docker images, and containers. Today, we are moving from theory to hands-on practice. Okay, here we are going to run our first Docker container. Okay, so let's start. Okay, before doing that, we have to set up Docker on our virtual machine. Am I right? So now I am going to use AWS virtual machine. Okay, first we will install Docker. Once we install the Docker, then we can proceed with building container. Okay, so I already installed the Docker, but still I'll explain how to set up Docker on your virtual machine. Okay, so here like I will attach my GitHub 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 repo link. Okay, so you can find a Docker installation for Ubuntu here. Okay, so using this you can set up Docker on your machine. Even if you don't have any cloud provider account, I'll suggest you to create one. Otherwise, at least set up at least install Docker setup, Docker desktop, so you can work with Docker containers. Okay, so first we will look into how to set up Docker on Ubuntu. Okay, even for example, if you are working with Docker with any other Linux flavor, I'll suggest you to install Docker in it and practice. Okay, you can just type in browser like how to install Docker on CentOS or how to install Docker on Red Hat. Okay, it is simple. Okay, and there are so many articles out there which describes how to set up Docker. Okay, so this is for Ubuntu. If you are going to work with Ubuntu, then you can come to my repo and you can use this. Okay, so first sudo apt update. Okay, so what it will do is it refreshes the Ubuntu package index, so apt knows about the latest versions and package locations. Why? Always run before installing new packages, so apt uses current package list. Okay, let me execute this command. Next is we are going to install dependencies. Okay, so what is the purpose of all these dependencies? Let me explain one by one. Okay, first is the thing is it installs packages required to securely add third party repos and download files. First is CA certificates. It's a tested CS certificates for HTTPS verification. Okay, and curl, it is utility to fetch files and URLs, and you can see GNUPG. It is for working with GPG keys. Okay, signing and verification, and you can see LSB release. Okay, which provides the Ubuntu release code name. Okay, use it later. Okay, so the thing is these tools are needed to add Docker's GPG key and repository correctly. Okay, and here I have used -y, right? What it will do is it answers yes to the prompt. Okay, so it will not ask confirmation to me. If I just click enter, it will set up. Okay, since I have already installed it, it's showing 0. Okay, so next command is we have to add Docker GPG key. Okay, so first we have to execute this command. What it will do, it will it will create a folder. Okay, like it creates /etc/apt keyrings. Okay, if does not exist. Okay, so it downloads Docker GPG public key and converts it into a binary keyring file. Okay, docker.gpg. Okay, so the thing is apt uses the GPG key to verify the packages downloaded from Docker repository. Okay, and here security note is storing the key in /etc/apt/keyrings and referencing it in the repo line is the recommended secure pattern. Okay, so you have to just execute this command. Okay, one by one. And it is, see, you can see it is already there, so I'm not going to override. So I'll just type n and click enter. I'll just cancel this. Okay, next is we have to add Docker repository. Yeah, adding Docker's official apt repository to our system by creating slash etc slash apt source dot list dot d slash docker dot list. Okay, here you can see uh, dpkg print architecture. It injects your system architecture. Okay, example AMD 64 or x84. Okay, next is you can see lsb. Where is that? Yeah, here you can see signed. What it will do is this tells apt to use the key you saved earlier to verify packages. Okay, this let you install docker packages from docker official stable channel rather than distro packages. Okay, so since after doing this, okay, again you have to do sudo apt update. Okay, so after that, in this command what we are doing is like we are installing docker and plugins. Okay, docker c is there, right? This is docker engine community edition. Docker c hyphen cli, which is docker command line client. Container d.io, container runtime used by docker. Docker buildx plugin. Okay, buildx plugin for advanced builds. Okay, in upcoming videos we will use build kit, multi arc builds and all. So for that we have to use that. For that we need this, so we are installing it. Next is docker compose plugin, compose v2 plugin. Okay, we will use for docker compose. Okay, these are the core components needed to build, run, orchestrate containers on Ubuntu. With docker compose you can use v2 legacy docker compose hyphen may not be installed. Okay, so after that, yeah, you can execute this. Okay, so what it will do, the thing is this command, user mod command is there, right? It adds your user to the docker unix group, so you can run docker command without sudo. This new group docker is there, right? It applies the group change in the current shell session, so you don't have to log out and back in. Okay, so it is for convenience. Okay, avoids running sudo for each docker command. Okay, important thing is adding a user to the docker group grants privilege similar to root for docker operations. Okay, be here you will get security implications also, but do by knowing it. Okay, with don't do without knowing it. Okay, so since we have already done since I have executed all these steps already, if I type docker version, you can see docker version, my docker compose version. Okay, better, since if you are new to docker, go with ubuntu machine. Okay, so you can just copy paste these instructions and you can try. And our first command, first container that we are going to run is docker run allow world. You can see it is printing allow from docker. what what's happening behind the scene, do you know? So the thing is, behind the scene, docker client sends this command to dockerd. Dockerd checks if that image is exits locally. Okay, it is already exits in locally. Okay, if I type docker images, let me type docker images, it is there, so it executed, otherwise it will pull from the docker hub. Okay, let me delete all these images so I can show you what happens if there is no image. So to delete images you have to use docker rmi, and you can use container id to delete, sorry, image id to delete. Why it's not deleting? Image is being stopped. Okay, let me delete all the stopped containers. We can start fresh. Okay, rm. Okay, stop. I'll just the best practice is, if container is running, first stop it, after that destroy it. Okay, that is the best practice. Okay, now I have destroyed all the containers. You can see I don't have any running containers as well as stopped or exited containers. Now I'll go to docker images and I'll destroy everything so we can start newly. I have destroyed everything. Now we are going to type hello world. Okay, we are going to print hello world. Okay, so docker run hello world. Here you can see unable to find image. Okay, locally. So it is pulling the images from the Docker hub. Okay, so behind the scene, what's happening? Docker client sends this command to Docker D. Docker D checks if image exists locally. It is not there. So if not, it pulls, right. So it pulls hello world from Docker hub. Then it creates a container and runs it. Okay, it prints a friendly message hello from Docker and exist. Now the thing is, if I type Docker PS, you can't see this in a running container. But if I type docker ps-a, you can see this in exited container. The thing is, have you noticed that it exited immediately? Why didn't it keep running like a virtual machine? Because containers live only as long as their main process does. Okay, so then how to keep containers alive? Okay, so let's have another example to make this interactive. Okay, so I'll this time what I'll do is, this is already an Ubuntu machine. All right, now what I am going to do is, I am going to create one Ubuntu container and I am going to create some folder there. While I'm inside that container, I am going to check whether it is showing something in docker ps. Okay, so docker, which means in running container list. Okay, docker ps, no, not docker ps, docker run -it ubuntu, and we can connect this container with bash, so we can able to access that container. Okay, now we are inside the container. I'll just clear this. Okay, let me duplicate this. Now I'll check, I'll use docker ps, docker ps. You can see it is showing as up. Okay, because currently we are inside the container, so container is alive. Okay, I'll create one folder called test. Okay, if I use ls, you can see the test folder here. Okay, now currently if you see here, it is in the up state, right, because it is alive. Okay, if I come out of this container, if I type docker ps, it is also not showing, right. If I use -a, it will show that in exited, because this time the container stays alive as long as you are in the shell. Okay, so and after coming out of that container, it exits, the container stops. Okay, so the thing is, when like it will be alive. Okay, as long as their main process does. Okay, so uh, can you think of what kind of processes should stay running in production containers? For that only we will use web servers, database, backend services and all to make it run. Okay, so let's play with the real example. Okay, so this time I'll set up nginx. Okay, so we try to run nginx in our ubuntu machine. Okay, so the command is docker run -d for detached mode, because it will run the process in the backend. -p for port. Okay, this is host port. Okay, in host I am using 8080 and in container I am using 80, and I am going to use nginx image. So we don't have that nginx image, so it is pulling from the docker hub. So here 8080 is the host port and 80 is the container port. Now I'll try to enter inside the container. For that I need to know container ID, right? So I'll just type docker ps. You can see for hello world and ubuntu and all, only for certain time it was up and up. Okay, after that it has exited. But for web servers you can see it is all it was always up and running. Okay, because this main process will be keep on running, so container also up. Okay, so now I'll enter inside the container and we will try to access our nginx welcome page. Okay, because we haven't done any setup, we are just cloned the, like we just pulled the nginx image, we are going to check whether nginx is going to work on our Docker container. Okay, so the command is docker exec for executable -it for interactive and container id, and I'll use shell to connect. Okay, this is shell. Now we are going to check that our nginx is working or not inside the container. For that I'll use curl, okay, http localhost colon, okay. Now within the container it will work with 8080 port, that only we have provided, right? So I'll just provide 80 here, and you can see welcome page is coming. Okay, so now I'll come out of this container. Even you can see it will be still running because it's a web server. Okay, now we will try to access the same application, okay, in our VM. This time host port is 8080, right? So we have to use curl http localhost 8080, and it is running successfully. Now we will try this with browser. Okay, so I'll just enter into the browser. Okay, now in browser you should not use localhost. Okay, if you are doing this in your cloud provider like AWS or Azure, you have to use public IP of that VM. Okay, so I have already copied the public IP of my VM, so I'll just paste that with port 8080 because host port is 8080. If I click enter, you can see welcome to nginx homepage. We haven't done any setup. Okay, we haven't written any custom code and all. We just like installed nginx and we can able to access it. Okay, so what do you think happens if you try to run two containers on 8080 port? So the problem will, you will get port conflict. Only one process per host port will be done. Okay, so next is we can explore and manage containers. Okay, so if I type docker ps, you can okay, if you want to see only running containers, then you can go with docker ps. If you want to check stopped containers or exited containers, or if there is any issue in any other containers, if you want to check, then you can use docker ps -a. You can see okay, spelling is wrong. Docker, you can see our hello world container, Ubuntu container, everything out there. Even running containers also it will show, but it will show as an app. Okay, so next is you can check logs for this container. Oh, with the help of docker logs command. So docker logs, just copy the container ID and paste it. You can check the logs here. Okay, in real time, if your application is not working, then with the help of these logs you can able to fix it easily. So docker ps, what it will do, it will show running containers. Docker logs, we can use to weave the logs. Docker exec, you can enter into the container because with the help of exec -it only we have entered into the container. Docker stop, what it will do, it will stop the container. Currently nginx is up and running, right? So if I type docker ps, it is up, you can see. Now if you want to stop, then what you have to do, you just type docker stop with container id. Now if I type docker ps, it will not show, but if you use -a, it will show. Okay, then you can ask, if I want to start, then what I have to do, just use, instead of stop, use start. Even you can restart. Okay, so it's like a service in Linux. Okay, you can start, stop, restart, all these things you can do it. Again you can see it will show. Okay, if you want to destroy, like initially we destroyed old containers, right? You can use docker rm for containers. Okay, for example, if I want to destroy these two images, means I can use docker rm and container id of it. So we destroyed it. If you want to destroy an image, then we have to type docker rm for remove, I for image, and you have to use image id. So if I type docker images, you can't see those images. Okay, So let's understand Docker images, which is blueprint analogy. Let's zoom out. Where do these containers come from? They came from Docker images, which is blueprints for container. Think of Docker image as a blueprint. Docker container is a house built from that blueprint. Okay, multiple houses containers can be built from one blueprint. Okay, so if you run 5 containers from the same image, does it take 5x disk space? Let me know in the comment section. The answer is no. They share the same read-only layers. Okay, so even last class we discussed. Okay, so if you are new to this channel, watch my previous video. Okay, in that video I have explained how images and containers works. Okay, so the thing is, it will use the read only layers, which means if the layers are same, it will not like install or update every time. Okay, it will use the same layers. So how it will differentiate? For example, if you have a image, okay, if you have a same image, consider nginx image. Okay, so let me zoom this. Even in interviews you can expect this kind of questions. Okay, I have nginx image. I am creating 2 containers. One is nginx1, another one is nginx2. Okay, in interview also they may ask, okay, if I change the image, okay, in nginx1 container, do it will be reflected in nginx2 container also, because it uses same image? If you know, just let me know in the comment section. Pause the video and let me know in the comment section. The thing is, no. Okay, because you will have an image. Okay, in the top of that you will have the writable layer. So whatever changes you will make in container, it will store in the writable layer only. So writable layer is different for each container. Okay, so in this writable layer, what change you made in nginx1 will not be available here. Okay, so if you make some changes in this container, it only will act accordingly, it will not act accordingly. Okay, because writable layers are different for each container, and containers are ephemeral in nature, which means now I am writing something in this writable layer, right? If I restart or if I stop it, I will lose it. It will die. All my changes will die. Okay, so only we have to use persistent volume. Okay, everything we will discuss in upcoming classes. Okay, we will go one by one. Okay, so till now understand this. Okay, next, how you can pull images from Docker Hub. Okay, we already know where to get Docker Hub, right? So let me just type Docker Hub on your browser. Okay, Docker Hub, and here you can search images. For example, if I type nginx, you can get nginx. Actually, if you can see this symbol, it indicates Docker official image, and if you see this tick symbol, it will be a verified publisher. Okay, so always use only official image and verified publisher. Don't use any other images. Okay, so you can pull. Okay, with the help of this command you can pull. Okay, here if you want only nginx, you can, based on the need, okay, you can pull. Okay, so this is the way to pull the image from Docker Hub. Okay, for example, consider MySQL. Okay, you need to work with MySQL, then now you can pull this. Just go to MySQL, go to official image of MySQL. Okay, I'll just copy this and I'll paste it. So image, now it is trying to pull images from Docker Hub. You can see layer by layer it is pulling. Once done, we can able to access it. So if I type Docker images, you can see the MySQL image. Okay, this is how we have to pull the own, you have to pull the images from Docker Hub. Okay, if you want to destroy it, then again you can use Docker or mine, and you can use image ID to destroy it. Okay, now let's build our own image. Okay, let's create a simple Python app. okay, and we will try to create our own image. Okay, so I'll create one folder called Python. Okay, Python project 1. This is just a simple project, okay, to make you understand how to build your own container. Okay, I'll create app.py, app.py, and I'll push this code into GitHub also. Okay, so if you want, you can get it from there. Okay, so I'll just use print statement, okay, because in real time it depends on your role. Okay, if you are a developer, then you will write code. Okay, if you're a DevOps engineer, then mostly you will not work on building applications, you will work on only creating Docker files, Docker images, okay, all those things. Okay, both are same. Only with the help of Docker file we will build Docker images. So I'll just print one statement like hello from my custom Docker image. Okay, just a simple Python application. Okay, now uh, actually to write your own Docker file, you need to know some key instructions. Okay, in next class we will discuss, there are nearly 15 plus key instructions out there that we will discuss in next class. Yeah, but in this class what we can do is the 5 widely used instructions I will teach. Okay, using that only we are going to write Docker file. Okay, first is from. Okay, this and all we will call it as a Docker key instructions. Okay, so next class I will teach all the 15 instructions. So for this class you just know 5, that is enough. Okay, key instructions for Docker file. Okay, first is from. Okay, from. Okay, the purpose of from key instruction is it specifies the base image for the Docker build. Currently how we are working, we have an Ubuntu OS in virtual machine, so we can able to perform operations, right? Like that, for container also you need some image, some OS to run your software. Okay, to pull that we will use from. Okay, second is run. The purpose of this run is it executes command in a new layer on the top of current image. The resulting layer is committed to the image. If you want to run anything inside the container, then you can use run. Third is copy. Purpose is it copies files and directories from the host machine to the image. Okay, add also is there, that we will discuss in next class. Okay, here we are going to use only copy. Work dir, working directory, it sets the working directory inside the container. So all subsequent commands after this what all commands you will execute, it will work in it will execute in this directory. Okay, okay, so next is cmd command. Cmd stands for command. Okay, the purpose of this key instruction is it specifies the default command to run when the container starts. For example, you consider one web framework. Okay, Django. Okay, Django is one of the Python web framework. Okay, if you are building your code on Django, okay, if you want to view your application, you have to run that code, right? For to run that, what you will use Python 3 and manage.py run server. Okay, this is the command to run Django application. Once you do this, you can see your web application in the browser. Okay, right? So the same thing only in container, if you want to run, you need a command. Okay, so in this command you will pass this command. Okay, so it will run your application inside the container, so you can able to access outside the container. Okay, so for this example we will use Flask. Okay, Flask also is one of the Python framework. Okay, Flask, Django, all are web framework. Okay, so now we will write Docker file. Okay, so vi Docker file. Okay, again we are going to use from Okay, you know the purpose of from, right? Just now we discussed. Now I'm going to use base image as a Python because I'm going to build a Python application, so I can directly use Python as a base image Python. So to reduce container image size, I'll just go with slim version. Okay, slim, and I'll use copy method, and we have written app.py, right? I'm just copying that from my virtual machine to my container. Okay, and I'm planning to copy this under app folder. So app underscore dot app dot py, and work directory. Now only I'm going to make work directory, so all subsequent commands will run on app folder. So I'll just provide app. Okay, command. Okay, this is Flask application. To run this application, we need the command will be Python and our app file. Okay, which is our app name is app.py, app file name is app.py. So I just provided it, and I'll close it. And you need to now you can build the container. Okay, so now we have a Docker file. Okay, to get Docker image, we have to build this Docker file. So the command to build this Docker file is docker build -t for tag, and I'll tag this as my Python app. Okay, since I have my Docker file in the current directory itself, I'll just use dot and I'll click enter. It is failed. Why? Any idea? Here there is an issue with our Docker file, so only we are getting issue. Okay, so what issue we have in our Docker file? Are you able to identify? The thing is, we haven't given any space between cmd and its command. Okay, there should be some space. Okay, now we have fixed it. Now let me execute it. Okay, so each instruction in a Docker file, it will create a separate layer. Okay, so how many lines we have written? If I use cat Docker file 1 2 3 4, so it will create 4 layers. Okay, in the top of that we will have writable layer. Okay, so you can see it is running command, right? So you can ignore it. So totally 3 layers, so it is creating totally 3 layers. In the top of that you will have writable layer. Okay, so now if I type docker ps, we will not have anything because we just created an image. So you can use docker images, and you can see this is our image, like this is the application that we have created. Now we have an image. Then how we can get a container, how to make this image to run in the container? For that, what we can do is we can use docker run command that we already done, right? So docker run -d for detached mode, and I'll run this app. If I type docker ps, you can't see this here, right? So if I type docker ps -a, it was exited. So if we can check logs. Okay, why it is exited? You can see allow from my docker image. Okay, after like you can say even why just not why you can run directly python app.py, right, instead of creating docker, because for reproducibility the same image runs anywhere. I already said, right, container live as the main process lives. Okay, it is executed it is like it is printed and it is exited. Okay, because here we are not using any web server or anything. Okay, to make it what I can say, to make it run, okay, like nginx. Okay, so you just I just created a simple application and I have executed it, and you can see that like output in the docker logs. Okay, so this is how we have to create an image. Okay, in upcoming classes we will build application, and we will create docker image, and we will run in the container, and we will do so many things. Okay, this is just a beginning, right? So we will go one by one. Okay, so Now we have created our image, right? Even if it is small image, we have created our first image, right? So even how like even you can store this image on the Docker hub. How you can do it? Okay, first what you have to do is you have to create one account in Docker hub. Okay, so just go here and do sign up. Okay, so just go to Docker hub and do sign up. Okay, so just click sign up and sign in with your Google account. Okay, once you've done that, you will have an account, right? So with the help of your account credentials you can do it. So let me open my account, just give me a minute. So now what we are going to do is we are just going to push our image into the Docker hub. Okay, the image that we have created, that we are going to push. Okay, so uh, so this is my Docker account. Okay, I have all my test images. Okay, so now what I'm going to do is I'm going to I'm going to push my Python image that I have created. Okay, so how to do this? First you have to type docker login. Okay, just copy this so it will authenticate. Okay, I'll just copy this and I'll go here and I'll paste this. It will ask to print one time code that I already received it here. I'll just copy this and I'll paste this. Confirm. So I have confirmed it. Okay, it is waiting. Login is success. Okay, now I am going to tag my image first. Okay, so docker tag my Python app and my username is Kishore EL. I hope. Just wait, I'll check. Yes, Kishore EL. I'll just copy this username. Okay, and I'll push this as a my Python. Instead of going with latest, I'll have app version name. Okay, my Python app version v1. Okay, if I do any changes in future, then I'll tag it as a v2. So if anyone want like in real time, if you're working in a company, then if you're making some changes based on this tag, they will understand whether it's new or old. If you're just using latest, they will not remember, right? They will not know, right, whether this is a new image or old image. Okay, to avoid confusion, just go with v1 v2. Okay, like that. Now I have just tagged it, right? Now I am going to push this. Okay, so the command is docker push. Okay, just copy this. So now I am pushing into Docker hub. Okay, so anyone can pull it. Okay, even if you want, you can pull it. Okay, so you can just use docker pull my username and okay, you can use, okay, instead of push, if you use pull, you can get this image. Okay, so if I go here and if I reload this, you can see my Python app. Okay, less than a minute ago I have created. Okay, here this is the command. Okay, even if you need, I'll just paste this link into description. Okay, so you can pull with the help of this command. Okay, so this is push command. Okay, so you can see if you want to pull v1, you can see all the layers and you can easily pull it. Okay, with the help of docker pull. Okay, so this is available publicly. I think this is public image only, right? Wait, let me check. Yeah, it's a public image. Okay, so this is how you have to push your images. Okay, again, if you want to clean up, again you can use docker rmi for images and docker rm for containers. Okay, so today what we learned, how to run your first Docker container, the difference between containers and image, how to build, tag and push custom images. Okay, if you like this breakdown, subscribe to Cloud Ops Craft. We will simplify cloud and DevOps concepts every week. Thank you. Hello everyone, welcome back to CloudOps Craft. Today we are going to deep dive into Dockerfile, writing your own image. Okay, so far we have been pulling ready-made images like Nginx and Redis, but here is the question: what if you need a custom app that's not available on Docker Hub? That's where Dockerfile comes in. Yeah, Dockerfile is like a recipe card for Docker. Instead of downloading a like a pre-cooked meal, which is public image, you are writing down your own recipe. Okay, Docker follows your recipe step by step to prepare the final dish, your custom image. Even in our last class, we written like a simple Docker file to deploy to deploy a Python application, right? So today, like even last class, I said we will learn Docker key instructions on next video, like that, right? So today, what we are going to do is first we are going to learn the key instructions that you need to know to write your own Docker file. So after knowing all the key instructions, we are going to write a Docker file. Okay, we are going to write our own Docker file. Okay, which is needed one. Okay, in real time, mostly we will pull the image from Docker Hub and we will write our own Docker file. Okay, so knowing how to write a Docker file is needed one. Okay, uh, in real time. Okay, let's start with the Docker keywords, which means like a Docker instructions define how to build a Docker image step by step. Okay, here is a detailed explanation of commonly used keywords. Okay, there are nearly 15 keywords out there. Okay, you have to understand it. Okay, so if you know that, you can write any Docker file for any application. Okay, by your own. Let's start. First key instruction is from. Even last class we have used it, right? From. The purpose of from keyword is it specifies the base image for the Docker build. Okay. Syntax is from. You have to use image name. Okay, and tag. Okay, if you are using if you are writing Docker file for multi-stage, okay, then you have to use as and alias. Okay, for example, you can write like from Ubuntu latest, or from node 16. Okay, or you can write from Alpine 3.18. What it will do, it uses Alpine Linux version 3.18. If you are using from node 16, what it will do, it uses it uses node.js version 16 as the base image. If you are using from Ubuntu latest, then it will use the latest Ubuntu image. Okay, so the second key instruction is work dir. Purpose is it sets the working directory inside the container. All subsequent commands like copy or run are executed related to this directory. So the syntax will be work dir and path. Okay, for example, work dir /user/src/app. Consider this as a path. Okay, so all subsequent commands will be executed in this path. Okay, so third key instruction is add. Okay, the purpose is it copies files and directories from the host machine into the image. It also supports extracting tar files automatically, fetching files from remote URLs. Syntax is add source destination. Okay, for example, if I have a tar file, okay, I have to copy from the tar file, means I can simply use add app dot tar.gz. Consider this as my tar file. I can easily copy this file contents into the app folder, okay, with the help of add. Next is copy. Purpose of copy is it copies files and directories from the host machine to the image. Unlike add, it does not extract tar files or support remote URLs. You can just copy the files, okay, from host machine to your image, okay. You can't do extraction, or you can't download the files from URL and all with the help of copy. Okay, that is the major difference between copy and add. Syntax will be same only, okay. So copy src destination, source and destination. Fifth is run. Okay, purpose is it executes command in a new layer on top of the current image. The resulting layer is committed to the image. The syntax should be run and the command that you are planning to run. Okay, for example, run npm install, so it will install node.js dependencies, okay, like that you can use. And next is cmd. Purpose is it specifies the default command to run when the container starts. The syntax should be cmd executable, and you can provide the parameters. Okay, for example, npm start. What it will do, it will run npm start when the container starts. Okay, so next key instruction is entry point. Purpose is it is similar to cmd, but it configures the container to run as an executable. It is better suited for containers that require command line arguments. So syntax is it is also similar like cmd only. Entry point executable parameter 1 comma parameter 2. Okay, example is, for example, if you are going to run python application, then you can write like entry point python app.py, like this. Okay, next is expose. It should be in capital letter. Okay, purpose is it declares the network ports on which the container will listen at runtime. Okay, syntax should be expose, and you can provide the port. For example, expose 3000. So what it will do, it will open port 3000 for the container. Okay, so the next key instruction is env. Okay, purpose is it sets the environmental variables in the container. Okay, so the syntax should be env key and value. Okay, so this is how we have to write. For example, env node env production, like this. 10th is volume. volume. What it will do, the purpose is it creates a mount point for a volume useful for persisting data. Syntax is volume and path. Okay, example is volume data. Okay, and next key instruction is arg, which is argument. Purpose is it defines the build time variables. These are not available in the running container. Okay, so it will be available only in build time, which means whenever you type docker build, okay, on this process only it will be like available. Okay, once you created a image, okay, then while running this arg is not available. Okay, only in build time you can able to access this. Okay, so the syntax is arg name and default. Okay, for example, you can set like arg version equal to 1.0, and you can call this like a from ubuntu, and you can call this arg like version here. Okay, so by default it will take 1.0, and you can change this on the build time. Okay, so the next is label. Okay, purpose is it adds the metadata to the image. Okay, so the syntax should be label key value. Label, for example, label maintainer, and you can provide your email address here. So like if they have any doubts or if they want to clarify something, then they will reach you. Okay, since you are the maintainer of this image. Okay, so the next is user. Okay, the purpose is it specifies the user to use when running the container. Okay, the syntax is username or uid. Okay, so you no need to remember all these key instructions. Okay, once you started working with docker, automatically you can able to remember all those things. Okay, so since right, all my videos are available in medium also. Okay, so if you want to revise all these key instructions, you no need to watch this video again. Okay, so just go to my medium profile. I'll attach that link in the description, so you can revise that. Before going into, just have a look into it if you are new to docker. Okay, so it will be really helpful for you, because in interview they will ask what and all key instructions you have used and all. So you must able to say list all the key instructions and its use cases and where you used it. Okay, so you no need to memorize this. Okay, so on once you started working on it, you can able to recall it whenever you are writing a docker file. Okay, so you can for example, how you can use this user 1001, like that you can use. Okay, so the next is on build. Any idea on this key instruction? If you have any idea, just pause this video and let me know in the comment section, so I can understand your perspective. Let me explain. The purpose is it adds a trigger instruction to the image. This runs when the image is used as a base image for another build. Okay, so the syntax should be on build, okay, instruction. Add app like this you can use. Okay, and next is health check. Any idea on it? Why we need health check? If you know, just pause this video and let me know in the comment section. Health check. It defines a command to test container health. Okay, so how you can write the syntax is health check, health check options, and you can provide the options, or you can provide the cmd command also here. Okay, based on your need. For example, how you can write is, if you want to test your health with the help of localhost, then you can write like health check cmd curl -f http localhost, okay, exit 1, like this you can write. Okay, so now you know the key instructions of Dockerfile. Okay, yeah, Dockerfile is just a text file with a list of instructions. Okay, each instruction creates a layer in the final image. Okay, so the typical structure will be there, right? So let me explain the typical structure of Dockerfile. So while coming to typical structure, we will use from, okay, for base image, and we will use run to install dependencies. We will use copy or add based on the need, okay, to bring your code in, okay, into the image. Next is work dir to set the working directory. Next is cmdr entry point. Okay, these key instructions must we will use, okay, to define default command. Okay, so this is how like this and all the key instructions are there, and this is the typical structure. Okay, so let me know, like I have a question for you. What do you think we need a base image like python 3.9 instead of starting from scratch? The thing is, it saves time, it avoids reinventing the wheel. Okay, so what we can do is, using these key instructions, now we will try to build a docker file, okay, for python app. Okay, and we will try to we will try to check whether it is working or not. Okay, so we will have a good understanding. Okay, so what we learned, that we are going to implement. Okay, so let's go to virtual machine. Here I am using aws virtual machine. Okay, in real time you can use any virtual machine from any cloud provider. Okay, so let's start. Even if you don't have a cloud virtual machine, also no issues. You can set up docker on your laptop itself. Okay, if you are using windows or mac, then just install docker desktop. Okay, so that is sufficient to do this. Okay, so let's start. I'll create one folder. Okay, I hope it is visible. Okay, so let me create a folder. And I'll enter into the folder. I'll just create some sample Flask app. Okay, so we can use that to deploy. Okay, so vi app.py. app.py, and I'll write some basic code only. Okay, in real time, as a DevOps engineer, you will not write application code, since for testing here I am writing. Okay, it will be written by backend developers only. Like application will be built by developers, right? Our job is we just containerize it. Okay, so for like a demo purpose, I'm just writing a simple application just to print allow from Dockerfile deep dive. Okay, this is the content that we are going to print. Actually, this is a Flask framework. Okay, the written message that we are going to print is allow from Dockerfile deep dive. And I'll just call this main app.run host port. I'll use port 5000. Okay, now we have written our app.py, which is our application code. Okay, so now what we are going to do, we are going to write a Docker file to containerize this application. Okay, so let's write the Docker file. Okay, first what we are going to do, we are going to create a file, okay, which is text file docker file. Okay, first we will start from to create a base image from Python. Since this is Python based application, I'll use Python as a base image, Python 3.9. I'll go with the slim. Okay, so my image size should be small, and I'll just use metadata. Okay, so label maintainer. Okay, maintainer is since this is since I'm posting this in YouTube, I'll just provide cloudopscraft at gmail.com. And now I'm going to create a non-root user and set work directory. Okay, so run command I'm going to use run. Okay, user add -m app user, and I'm going to make my work directory work dir as app folder. So all my subsequent commands will run under app folder. Now I'm going to copy code before installing dependencies. Okay, so I have app.py, right? I'm just going to copy that into my app folder in the image. Okay, so copy app.py, and I'm just going to copy that inside my Docker image app folder. Now I'm going to switch to non-root user before running pip. Okay, so I'm just switching with the help of user app user. This is my username. Okay, so now only I'm going to install dependencies using -user flag. Okay, so run pip install -user flask. Okay, so do you have any idea why I am using -user and I am running flask? Any idea? If you know, let me know on the comment section. Okay, even this is a YouTube recorded video. Okay, I want it to be interactive. So whenever I ask a question, if you're watching this video, okay, so just let me know your thoughts on the comment section. Okay, so I can understand like how you are thinking. Okay, so just pause the video and think and just let me know in the comment section why we are using hyphen user flask. Okay, because we can simply use a pip install flask also, right? Run pip install flask, but we are using hyphen user, right? The reason is to install Python package flask into the non-root user home directory instead of installing globally. Okay, so you are telling pip that install this package into the user's local site packages folder, not system wide. Okay, so where does it install? It installs into home slash app user slash dot local slash lib slash python 3.9. Under site packages it will install. Okay, instead of by default, if you are just providing run pip install flask, it will install on user local lib, okay, python 3.9 site packages folder. Okay, why this is needed in your docker file? Because you switched, like what we done, we switched the user to app user before installing dependencies, which is user app user. Okay, and non-root users cannot install global packages system wide since they don't have write permission. Okay, so if we use pip install flask, obviously it could fail. So only to avoid failing, I'm just using pip install hyphen user flask. Okay, it fixes by installing flask locally for app user. Okay, so if I use run pip install flask, means it installs globally, it requires root permission. But if I use pip install hyphen user flask, it installs to user's home directory, works without root. Okay, so this is the concept behind this. Okay, now I am going to expose port and run the app, and I'll expose this into 5000 port, and I'll run the command cmd python python app.py, since I created name as app.py. Okay, okay, so let's save this. Now how to build a docker file? Do you remember how to build docker file? There is a command, right? The command is docker build. Okay, so docker build hyphen t for tag, and I'll name this as a flask allow. Okay, my image name. Okay, since I have my docker file on the current directory, I'll just use dot here. Okay, it is for each instruction it will create a layer. Okay, so let's wait it. You can see one warning, right? Yeah, any idea why we are getting it? Do you know why we are getting this uh, warning? So if you open my docker file, you can see I have used label maintainer equal to like that, right? Actually, Docker recommends using label key and its value, right? Instead of the old legacy format. Okay, our docker file currently has this. Okay, this is correct and already in the recommended format only, but docker is confused because older docker versions allowed label maintainer, and you don't need to provide equal, and you can just provide your email. Okay, But why we are getting this error? Actually we have some space here, right? So we just fix this space. Okay, we just have to remove the maintainer label. Like what I can say, we just need to uh, instead of using label, we can go with official recommendation. Okay, so instead of using label we can use like instead of maintainer, okay, not label. Instead of maintainer we can go with org.opencontainers.image.authors, like that we can use. Okay, and even you can remove space also. If you remove space also it will work, I hope. Just we will test this. Okay, so now we will try to run this. If it is not working, then we can go with org.opencontainers.image.authors. Okay, it is finished. Like just I'll go with Docker images. I'll delete all these images and we will build it newly. Okay, so we can know, so it will build from scratch. Okay, since in last class we created few containers, right, some of the images using that also, just we will destroy everything. Okay, now I have deleted all the images. Now I'll build it again. Okay, it is finished. Okay, so the thing is, previously we have used some gap. Okay, so only we got that warning. Okay, so we can go with this as well as label is must. Okay, you can go with maintainer, or you can even use description, or you can use org.opencontainers.image.authors also. Okay, that is the official recommendation. Okay, so like if I type docker images, we can see the image, right? Now what's the next step? We have to run that, okay, into the container. So the command is docker docker run -d for detached mode to run the container process in the backend, -p for port. Okay, so host port 5000, and I'm just going to use container port also 5000. Okay, flask hello, this is my image name, right? If I type docker like a ps to check the running containers, you can see the running container here. Okay, here actually we are using aws virtual machine. Okay, so since we are using aws virtual machine, in your security group you need to allow port 5000, otherwise it will not work. Okay, so what you have to do is you have to go to your aws virtual machine, which and you have to go to associated security group. Okay, so and just click edit inbound role and allow port 5000. Okay, and allow port 5000, so you can able to access this. Okay, I have already allowed it. Okay, so I can able to access it with the help of public ip of my ec2 machine. Okay, so if I that is simple, right? You just need to update the security group with like 5000 port. Okay, you have to update your inbound roles. Okay, so once you done that, just go to the browser. Okay, let me open browser, and your public IP and 5000 port. So you can see allow from Dockerfile deep dive. Okay, so this is the web page that we have built, we have containerized. Okay, you can even check Docker logs, you can using Docker logs and container ID. Okay, here you can check the logs. Okay, so we have deployed our application successfully. This is how you have to write your own Docker file. Okay, so I hope you understood, and while writing Docker file you need to follow some best practices. That best practice is to make Docker files efficient and secure. Use small images like Alpine to reduce size. Combine run commands to minimize layers. Use Docker ignore to avoid copying unnecessary files. Always pin versions. Okay, 3.9, 3.10, like that for consistency. Avoid running as a root when possible. Now you can see we have written a Docker file, but we haven't used root user. We just created our own user and we installed our app also in our user. Okay, so that is a good practice. Okay, so let's recap. Okay, we learned what a Docker file is and why we need it, and we broke down each instructions. Okay, from to uh, like all the 15 key instructions, and we built a real Flask app image. Okay, we just containerized the Flask app. Okay, and we covered best practices and debugging. And okay, so this is all about today. Okay, if you like this breakdown, subscribe to Cloud Ops Craft. We will simplify cloud and DevOps concepts every week. Thank you. Hello everyone, welcome back to Cloud Ops Craft. In our Docker series, today we are going to learn about Docker volumes. Okay, persistent data between containers. Okay, let's start. Actually, so far we have been happily running containers, but here's a problem. If you stop or delete a container, its data disappears. Let's test it first. Okay, so I am using AWS virtual machine. Like in previous videos and all, I have used VM, right? The same VM. Okay, so let's test this. Okay, what I said, if you stop or delete a container, data is disappearing, right? So first we will test that, and for that solution only Docker volumes. After that we will learn Docker volumes. Okay, so let's test it. Okay, so if I type Docker images, I have this image, I'll delete this. Okay, Docker RMI. Okay, Docker PS, I don't have any running containers. Docker PS hyphen a. Okay, first I'll delete the container. Okay, now I'll delete the image. Okay, both has been deleted. Docker images, I don't have anything. Now we will test. Okay, Docker run hyphen it Ubuntu. Okay, we are just using Ubuntu image, and we are going to just save some file, and we are going to test it after by stopping it. Okay, so git bash. Now it is pulling the image. Since we don't have Ubuntu image, now we are inside the container. Okay, I'm just going to write one text file. Okay, so echo hello Docker, hello Docker, and I will save this in hello.txt. Okay, now I am going to exit. Okay, if I type Docker PS, this is short-lived container. Okay, it will not be in a Docker PS. Okay, it will be in Docker PS until you use the terminal. It will be running. Once you exit the terminal, it will stop. Okay, now again I'm going to, now I stopped it, right? Like which means we exited, right? Now again I'm going to start this. Okay, Docker start hyphen AI container ID. Okay, now we are inside the terminal. Okay, now if I cat allo.txt, you can still see the allo.txt file, right? Now I am going to delete this container. Okay, now I am going to delete this container, docker ps-a, okay, docker rm, and I am going to destroy this container. Now I have destroyed it. Now again I am going to run the container, run the ubuntu container. Okay, docker run -it ubuntu bash. Okay, now if I do ls, we don't have. If I do cat allo.txt, no such file or directory. This happens because each container has its own isolated file system. When the container dies, data also will die. Okay, so to resolve this issue only, docker volumes is there. Okay, volumes are docker solution to persistence. Okay, they are stored outside the container lifecycle, managed by docker. Even if your container is deleted, volume remains. Okay, volume can be shared between multiple containers. Okay, container is like a temporary whiteboard. A volume is like a permanent notebook where you store important notes. Okay, so let's start. Types of containers, types of storage in docker. Okay, docker supports three main approaches. Okay, while coming to types of storages, let me zoom this. Okay, types of storage. Okay, first one is volumes. Okay, volumes is recommended one. Okay, second one is bind mounts. Third one is temporary fs mounts. Okay, first is volumes, which is recommended one. Okay, which is the recommended. Okay, so it is stored in docker managed area. Okay, the path will be /var /lib /docker /volumes. Okay, it is independent of containers. Okay, so next is bind mounts. Okay, in bind mounts, it maps a directory from your host machine into the container, useful for local development. Okay, third one is temporary fs mounts. Okay, it stores data in memory only, it disappears on restart. Okay, volumes is managed by docker. Bind mounts, which is host folder mapped inside container. Temporary fs is ram only, no persistence. Okay, so if I ask a question, which type could you use for sensitive temporary data like session caches means, you must go with temporary fs. Okay, for this kind of scenario. Okay, now let's create a volume. Okay, let's create and use a named volume. Okay, so now I am going to create a volume. Okay, the command is docker. Now we are going to create a named volume. Okay, docker volume create my data. Okay, I am just creating one volume called my data. What it does, this command creates a docker managed volume called my data. Okay, volumes are stored under docker internal path. Okay, on Linux usually under /var /lib /lib docker volumes. Okay, we have to use sudo. Okay, just wait. I'll enter as a root user. Okay, cd /var /lib /docker volumes. Okay, here you can see my data which we have created. Okay, if I go my inside my data, I will have underscore data folder. Here you can see Okay, it's completely independent of containers, meaning even if all containers are deleted, their data remains. Think of it as a permanent storage folder managed by Docker. Okay, so now how to use? We have created the uh, we have created the volume. Then how to use that volume? Okay, you may have this doubt, right? How to use that volume? Okay, so let's run with volume. Okay, so Docker run -d for detached mode, -v for volume, because we are going to mount the volume, so we have to use volume. Okay, my data. Okay, this is our volume name, and we are going to mount that under /app/data. Okay, slow /app/data. Okay, and name I'll just give as volume test. Okay, and the sleep is infinity. Oh, okay, so if I run this, we are getting some issue. Are you able to find that, are you able to understand what is the issue? Because here you can see we have used three underscores, three hyphens. Okay, there should be only two hyphens for name. Okay, now we are getting uh, pull access denied for sleep. Repository does not contain or may require Docker login. Okay, so how to fix this? Now actually I'll do Docker login. Okay, I'll exit of this. Okay, I already did Docker login. Just check. Okay, we need a Docker login. Okay, I'll do it. Okay, login is succeed because I have already logged in into it. Okay, so now I am going to run this. But again we are getting issue, but we are already done Docker login also, right? Then why we are getting this issue? Any idea? Because we have to use Ubuntu image, right? I haven't used Ubuntu here. Here you can see volume name is wall test. We are going to do this test in Ubuntu image, right? I haven't mentioned the image name, that's why it's not working. Now you can see it has created the container. If I do docker ps, I can see the running container. Okay, so docker run, what it will do, it start a new container -d, a run in detached mode, which is background mode. Okay, -v. Okay, here we are mounting the named volume my data into containers /app/data directory. Okay, left side we have, right, which is my data docker volume name. Right side is path inside the container name wall test. Okay, gives the container a custom name. Here you can see wall test. Okay, I just given container name as volume test. Okay, in short form. Ubuntu is the image used to create the container. Okay, sleep infinity, which means keeps the container running indefinitely. Okay, otherwise it could stop immediately, like allow build, like in previous classes we done, right, like that. Okay, to make it run as a long process I did this. Okay, what happens internally? Docker does these steps. Okay, it creates a new container from the Ubuntu image. It mounts the volume my data into containers /app/data directory. It starts running the command sleep infinity inside. Okay, which never ends, keeping the container alive. Okay, now we are going to access the container. Okay, how to access the container? With the help of exec-it interactive terminal. Okay, docker exec-it. Okay, our container name is volume test. Okay, and bash I'm going to use to access this terminal. Okay, now here docker exec is there, right? It's a it run a command inside a running container. Okay, -it is interactive terminal. Okay, it lets you use the terminal. Volume test is our target container name. Bash is the command you are executing inside. It opens a bash shell. Okay, now we are inside the volume test container. Okay, now we are going to save some data. Okay, so echo saved in volume. and I am going to write this data under app data, because in app data only I have mounted my volume, right? So slash app slash data, okay, slash file dot txt. Okay, now done. Okay, what it will do, it will create a file. Okay, I can access that file. Okay, app data file.txt, you can see saved in volume. This is the content of that file. Okay, so since slash app slash data is mounted from the named volume my data, this file is actually stored on the volume, not just inside the container file system. Even if you delete this container, the file will remain inside the volume. Okay, now we are going to exit the container. Okay, if you type exit, okay, it closes your shell session and returns to the host terminal. Okay, this container vault test is still running. You can see docker ps. Okay, since it's running sleep infinity. Okay, now I'm going to remove the container. Okay, so docker rm -f, because it is running, so I'm forcefully deleting it. Okay, container name is vault test. Okay, it has been deleted. If I use docker ps, you can't see that here after. It is okay. It is not, it is our old container. Okay, it's not our vault test. You can see the name. Okay, so docker rm, what it will do, it will remove a container. -f means forces stop and removal. Okay, if it is still running. Okay, now the container is gone, but the volume my data is still exit. How you can check? Docker volume ls, you can see my data is still there. Okay, because docker volume is live independently of containers. Okay, we can reuse the same volume in a new container. Okay, now we are going to create a new container and we are going to check, okay, whether our file is there or not. Okay, because for that purpose only we are using docker container, right? So docker rn, this time I'll just go directly interactive. Okay, -v for volume, my data is my volume name slash app slash data. Okay, ubuntu. Okay, I'll just use cat and I'll try to open my file directly, app slash data data slash file dot txt. Okay, you can see saved in volume, because even after destroying the container you can able to see this, because we stored our data in docker volume. Okay, if I use docker ps-a, you can see this is the new container that we created now. Okay, because here we haven't used sleep infinite. Okay, so it is stopped. Okay, once we exited. Okay, so docker run -it, what it's doing, it ran a new container interactively. -v my data colon slash app slash data mounts the same my data volume again. Here ubuntu is the ubuntu image that we have used, and this is the file path. Read and display the content of the file stored earlier. So now we can see the content that we previously stored in a previous container. That proves that file persisted even after the previous container was deleted. Okay, this is the major use case of docker volume. Okay, what we just proved it, docker volume, like even if you destroy the container, docker the data you stored in volume will be there. Okay, you can reuse it with new containers. Okay, so now we will discuss about using bind mounts. Okay, in 3 types. This is the widely used. Okay, in production and all we will go with volumes only. Okay, it is widely used and which is the recommended way. Okay, so we know how to handle this. Now we will discuss about bind mounts and temporary affairs. Okay, what is a bind mount? Bind mount connects a real folder from your host machine to a folder inside the container. Unlike volumes, which are managed entirely by Docker, bind mounts directly link your local file system to the container file system. So when you change a file on your host, it instantly updates inside the container and vice versa. This is why bind mounts are perfect for development. Okay, so Now we will just do a bind mount. Okay, so I don't have nginx, right? Or like, let's have an example. Okay, this is my current directory. Okay, I'll just create one HTML folder. Okay, dir, this is my host machine. Okay, I'm just storing HTML folder. Okay, I'll go inside it and I'll just create one text sample dot html. Okay, okay, this is sample and I'll close the tag. Okay, I'll come out of this. Okay, now we have HTML folder here. Okay, now I'm going to create a bind mount. Okay, so docker run -d for detached mode, -p for port. Okay, port I'm giving host port as 8080, container port as 80. Okay, -v for volume. Okay, dollar symbol. pwd is my current working directory /html. Okay, this is my host path. Okay, now I am going to give container path because I am going to use nginx image this time. Okay, /user /stash/nginx /html. Okay, and I am going to use nginx image, right? So let's click enter. It's pulling nginx image because it is not there. Okay, so let me explain. Docker run -d, what it does, it runs a new container in detached mode, which is background mode -p. Okay, and we have given port here. Host port is 8080 and the container port is 80. Okay, so you can access the container web server at localhost colon 8080. Okay, so here you can see. Okay, this is the core part. This creates the bind mount. Okay, here you can see left side part, it refers to the HTML folder inside our current working directory on the host. Okay, which is this HTML folder. Okay, on the host. Okay, which is our AWS VM. Okay, next is this user share nginx HTML. This is where nginx serves web files from inside the container, meaning your local folder .html replaces the container's default web root. Okay, nginx is the official image we have used here. What happens here internally? It starts a new container from the nginx image. It checks your host directory. Okay, which is this directory, that only we are calling it here. Okay, if it exists, mount it. If not, it creates it automatically. Anything you put in that HTML folder now appears inside the container under /user/share/nginx/html folder. Nginx serves those files immediately at URL. Okay, for example, if I use curl, okay, http localhost, okay, 8080, since I am running outside the container, right? Okay, we are getting forbidden. Any idea? Because I think I am not allowing this 880 port. Let me check in my security group. 8080. Okay, first we will check inside the container. After that we will check outside the container. Okay, so let's go inside the container. Okay, how to enter into the container? Just to check our HTML folder. Okay, so docker exec -it. We don't know our container ID, right? I'll just use docker ps. Okay, so here is container ID. So docker exec -it, my container ID, bash. First we will check, we created one text, like one HTML file inside HTML, right? Whether it is there or not, first we will check, because That is the purpose of bind mount, right? So slash user share nginx html. If I do ls, you can see sample dot html that we stored. If I use cat, you can see that here. Okay, now inside the container we will try to run this. Why we are getting this issue? Any idea? Any idea why we are getting this? We are getting no such file or directory. Why? Any idea? Do you know why we are getting that? See, we are getting this issue. Why? Because I want this class to be interactive, so I asked this question. If you know the answer, just let pause the video and let me know on the comment section, so I can understand whether you predicted it. Because it is not the command, because you have to use curl, right? Without using curl, you are running just HTTP, then how it will work? Okay. Again, we are getting forbidden issues. Why? Any idea why we are getting a forbidden? Do you know the answer? We can see we are getting forbidden. Again, if you know this, just let me know on the comment section. The thing is, by default it uses index.html, okay, but we have used sample.html, right? So we will try to change. Okay, again I'll connect my container here. Okay, so I'll enter into HTML folder. I'll um, rename this to index.html. Okay, now I renamed. We will just check whether it is reflected or not. Yeah, within fraction of seconds it has been reflected. Now you can see we are getting this p tag. Okay, because it takes by default index.html only. Okay, so we have to use index.html. But you can ask now, if it is sample.html, why it is not working? Because you have to call the name, because I haven't called any name. If you are not calling any name, it will check for index.html only. Again I'll switch to sample.html, it will work, but we have to call that. Okay, so index.html to sample.html. Okay, now you can see it is sample.html. Do you think it will not work? Obviously it will work, but just use sample.html. You have to call by name. Okay, if you call by name, obviously you can save with any name, it will work. Okay, so this is how bind mounts works. Okay, I hope you clear. If you have any queries, let me know on the comment section, so I will clarify your doubts. Okay, now you know how to handle bind mount and bind mount as well as volumes, right? Now let's have some hands on for temporary fs. Okay, so how to work with temporary fs? Any idea? If you know, just let me know in the comment section, because you know how bind mount works and how volumes works, right? So if I want to test with the temporary fs, okay, okay, how to use temporary fs, just let me know on the comment section, so I can understand like how you creating. Okay, okay, let me do it. Okay, let me do it. Let's have an example with temporary fs, okay, which is very fast, automatically cleared on reboot, useful for catching temp files and speed critical data. Okay, I'll come out of this. Okay, now let's create one temporary mode. Okay, sudo mkdir slash mnt slash ram disk. Okay, so now I'm going to do mount with the tmpfs. Okay, uh, but now we are going to do this with docker, right? So again we have to run that container, right? So like now we have created the mount point. Now how we can call this? It is easy. Okay, it is like a similar like what we did. Okay, so what you can do is docker. Okay, better let's make it simple. Okay, we can create a catchy folder in ram. Okay, so uh, let's come out of this. Everything is in catchy will be stored in the memory, right? So where to find catchy folder? Any idea? Since we are making it simple, where to find this? Where to find a catchy folder? Any idea? If you know, just let me know on the comment section. The reason for asking questions and doing it is so you will understand, like you will watch this like a live class. Okay, so just to create that only I am doing it. Okay, we can just run directly. Okay, docker run. Okay, so docker run hyphen it for interactive terminal hyphen rm, because it will, we can delete this after this. tmpfs slash catchy. Okay, alpine as such, alpine as such. Docker creates a temporary in-memory folder inside the container at slash catchy. Okay, you can see catchy. Okay, I'll enter into it slash catchy. Okay, I'll just create one file. Okay, now if I do ls, you can see this, right? The thing is here, very important thing is this slash catchy does not exist on your host. You can't see this slash catchy via EC2 or local machine. It lives only inside the container's memory. It disappears when the container stops. Okay, why you can't find slash catchy on the host? Because TMP temporary FS is not a folder on disk. It's not a volume. It's not a bind mode. It's stored only in container RAM. Okay, deleted when container exists. So after you exit the container, catchy is gone. Okay, so this is all about temporary FS. Now you know how to work with volumes, how to work with bind modes, how to work with the TMPFS, right? So so this is the needed one for Docker volumes. Okay, apart from this, if you want to inspect and manage volumes, I will provide some commands now, so you can use that to inspect. Okay, you can use Docker volume ls, okay, to list all your volumes. If you want to inspect your volume also, it's possible. Okay, you can use docker volume inspect my data. This is our volume, right? So you can inspect it. Okay, even you can delete it. Okay, with the help of rm, because volume it is in use, so you can't delete it. So first you have to detach, after that only you have to delete it. Okay, so ls for list volumes, docker volume inspect for seeing details, docker rm for remove one, docker volume if you want to clean unused volumes, then you can use docker volume. Okay, this command will delete unused volumes. Okay, because we don't have any unused volumes, so it was 0 MB was deleted. Okay, the best practice with volumes is always use named volumes for data you want docker to manage, which is we created a docker create volume, right? You can go with volumes. Okay, instead of bind mounts or temporary affairs. Okay, use bind mounts for local development, not production. Okay, always backup volumes in production. You can combine this with docker ignore to avoid bloating images. Document your volume mappings in readme for your team. Okay, if you like this breakdown, subscribe to CloudOpsCraft. We will simplify cloud and DevOps concepts every week. Thank you. Hello everyone, welcome back to CloudOpsCraft. Today we are going to discuss about Docker networking. Okay, so until now we have been running containers like little island. Okay, but real world apps need communication. For example, a front end container, React or Angular, talks to backend API, Node.js or Flask. Okay, yeah, backend talks to database, right? Without Docker networking, each container could be isolated. Okay, imagine a group of houses without roads, which is network. The house cannot communicate or reach the city. Docker network, Docker networks equal to roads. Okay, so Docker networking basics. Okay, by default, Docker provides three network drivers. Okay, so first one is bridge. Okay, by default, Docker provides three network drivers. Let me zoom this. Okay, first is bridge, which is default network. Second is host. Third one is none. Okay, you can also create custom bridge networks for more control. Okay, you can run this to see them. Okay, you can do docker network ls. Okay, it will show what and all network drivers you have. Okay, so you can see bridge, host, none, right? First we will discuss about bridge network, which is default network. Okay, so bridge network is the Docker's default. If you don't specify a network, containers joins the bridge. Okay, each container gets the private IP inside the bridge network. They can talk to each other using IP address. To talk to your host machine, you need port forwarding, which is IP. Okay, in our previous videos, we have used IP for port mapping, right? So that is the thing, because we went with bridge network. Okay, for example, if I do docker run -d for detached mode, name web1. Okay, -p for port is 8080 colon 80. Okay, and I'm going to use nginx image. Okay, so if I do docker ps, I can see the like this is not the running container. What error I am getting? Okay, why we are getting this issue? Because this port is already allocated. Okay, I'm just destroy this old container docker rm. It is up and running, so I'll delete it forcefully. Okay, so now again I'll run this, but still we are getting some more issue because we have already web1 like that it is showing. Let's use docker ps -a. Okay, got it, because we already created, right, one container. Previously we have executor, no, so that is creating this issue. I'll just remove all these things. Okay, I deleted everything. Okay, so now it created. Okay, so now by default we haven't provided any network, so it uses bridge network. So how to know whether it uses bridge network? You can use docker inspect and your container id. Okay, so here how you can check whether we are using bridge network? Go to networks. Here you can see. Okay, here we are using bridge network. By default it uses bridge network. Okay, so while coming to host network, with host networking the container shares the host network stack. No port mapping is needed. Okay, performance is slightly better since there is no network translation, but less isolation. Okay, security risk. For example, now I'll just create the same nginx with host. Okay, host network docker run hyphen network, because since previously we created the default network, I haven't mentioned any network called bridge, but this time I'm going to use host network, so I'm just providing host. Okay, network host and image is nginx. Now nginx is directly accessible on port 80 of the host. Okay, the thing is host network stack will be connected to our container. Okay, so if I do docker ps, I can't see this in a running container hyphen a. Yeah, this is the one. I'll just use docker inspect. Here you can see in the network we are using host one. Okay, so next is none network. If you run a container with the network none, it has no network access at all. Useful for security, completely isolated. Container can still do local compute tasks but no internet. Okay, for example, if I use docker run hyphen it hyphen network none ubuntu. Okay, now we are inside, right? If I ping google.com, it will fail. Actually, before that, we are getting ping not found. Okay, so like how to fix this issue? Any idea? How to fix this? We are getting, since we are running in Ubuntu image, we are getting this. Then how to fix this? If you know, let me know on the comment section. Because ping is not installed in the Ubuntu Docker image. Okay, so just I'll do apt update. This is just for testing, right? After that I'll install utilities ping. Okay, but I can't even download anything because I am using none network. So only you can see even my like apt update has been failed. Obviously I can't install without internet, you can see. Command not found. Oh, okay, apt. I can't install because there is no internet. Okay, so there is a thing of none network. Okay, if you want complete isolation, then you can go with none network. Okay, so next is custom bridge network. The real power comes when you create custom network. Okay, containers in the same custom bridge network can talk to each other by name. Okay, not just IP. Great for multi container apps. Okay, let's create our own network. Okay, docker network create my network. Okay, now if I do docker network ls, you can see my network. Okay, now I am going to run on my network. Okay, so docker run hyphen d for detached mode hyphen name db hyphen network. I'll go to I'll use my network which I have created. I'll use MySQL image. I'll go with MySQLite. Okay, hyphen e MySQL underscore root underscore password equal to pass123. Now again we will create one more container. Okay, just wait, let it run. Okay, now we will create another container. Okay, docker run hyphen d hyphen name app hyphen network my network hyphen p for port. I'll use 5000 port. flask app. Now our app container can connect to DB simply using the host name DB. Okay, so this is the advantage of creating your own network. But what is the issue we are getting? Okay, I don't have the Flask app, right? That's why we are getting. You can just use any image. What image we can use? I'll just use Flask. Okay, maybe Flask maybe not exist. I'll just use Python otherwise. Now the thing is, now my app container can connect to DB simply using host DB. Okay, so you can inspect your network. Okay, that we will do once it's executed. Okay, once you inspect, it will show IP address, subnet details, connected containers. Okay, so Docker network inspect my network. Oh, okay, network spelling is wrong. Here, if I go, you can see IP range, gateway, subnet. Okay, and containers, my network. Here you can get all these details. Okay, IPs in use is 3, dynamic IPs available, everything you can get. Okay, so the thing is, like Docker network plays a major role. Okay, so like now you know how to create your container, how to attach that into you like how to create your custom container and how you can attach that into your app container. Okay, if you want to delete network, then you can use Docker network rm network to delete. Okay, so the thing is, bridge, where you can use bridges, default with the port mapping you can go with bridge. Host is directly on host networks, none is isolated. Custom networks is named communication between containers. Okay, so for that you can go with like a custom network. Okay, so this is all about Docker networking. Okay, if you like this breakdown, subscribe to CloudOps Craft. We will simplify cloud and DevOps concepts every week. Thank you. Hello everyone, welcome back to CloudOps Craft. Today we are going to discuss about Docker Compose, managing multiple multi-container applications. Okay, if you didn't watch the previous videos, I suggest you to watch that, so you will have a continuity. Okay, so you can I'll attach playlist link in the description, so you check it and watch previous videos if you didn't. Okay, so you can if you watch previous videos, you can able to understand this clearly. Okay, so okay, so far we have been spinning up containers individually. That works for demos, but real apps are not just one container, right? A real world web app usually has a front end, it may be with React, Angular or Nginx, a backend with Node.js or Flask or Spring Boot, and a database with MySQL or PostgreSQL, maybe a cache with Redis. Okay, imagine starting each container manually, setting networks, volumes, and environments variable every time. Nightmare, right? So this is where Docker Compose saves the day. Okay, running multiple containers manually is like turning on all the lights in your house, one switch at a time. Okay, Docker Compose is the master switch. One file, one command, everything runs. Okay, so instead of running Docker and front end, Docker and back end, Docker and database, we are just going to spin up all the containers with the help of Docker Compose of up command. Okay, that's the thing. Okay, simply by typing Docker Compose up, what it will do, it everything runs together. Okay, so what is a Docker Compose? You may have this question, right? What is Docker Compose? Actually, Docker Compose is a tool to define and manage multi-container apps in a single YAML file. It lets you declare service, networks, and volumes in one place, runs everything. Okay, it will runs everything. Okay, whenever you run Docker Compose up. Okay, Docker Compose is like a YAML blueprint. Okay, so first on most systems Docker desktop already includes Docker Compose. Okay, but in our case, last time, like in initial class, what we done, we just installed Docker. Okay, so now what we can do is we can install Docker Compose first. After that we will work with Docker Compose. Okay, so Docker Compose up means it will start everything. Okay, Docker Compose down. Down means it will stop and do cleanup. Next is Docker Compose PS means it will list running service. Okay, so Docker Compose up, what it will do, it will start all the services. Docker hyphen compose down, what it will do, it will stop all the services. Okay, Docker Compose pages, it will show running containers. Okay, let's install Docker and we can have a real time example. Okay, we will deploy a application with the Docker Compose. Since you already know how to write a Docker file, you can easily write Docker Compose also. Okay, if you don't know how to write a Docker file, then watch my previous video so you can able to write. Okay, let's go to server. Okay, this is my server. If I type Docker hyphen compose hyphen version, see, I don't have Docker Compose. Okay, so let me install that. Before installing it, I have to I'll update my server. Okay, so sudo apt update. Okay, now we have updated our server. Now we will install Docker Compose. Now we are going to create a multi-container app. Okay, so let me explain the project structure. Okay, so our project structure should be, we will have one folder called multi-container app. Inside that we will have app.py. We will build our code with Flask. Okay, and we will have requirements.txt file to store our requirements. Okay, and we will have Docker file, and we will have Docker compose.yaml. Docker compose is an YAML file. Okay, okay, this is the structure we are going to create. Okay, let's start. So folder mkdir. Okay, and folder name is multi container app. Let me enter into it. Now I am going to create app.py. It's just a small app, like a simple app.py. Okay, since we are not developers, we are just creating sample application just to run our application into the container. Okay, so I'll first import Redis, because we are going to use multiple service here for this Docker Compose. Okay, so from Flask import Flask. In real time you will not write backend code. Okay, I am just writing here for demo. Let me complete this. It's just a simple app. Okay, just to print like just to, whenever we reload the page, it will show the count how many times you hit refresh button. Okay, app and catchy, I'll catch you this redis dot redis host also redis host equal to redis, and I'll provide port of redis is 6379. Okay, actually for port we don't need this. Okay, catchy and app root dev allow we are going to first get the count. Catchy dot inco it's written. If you are unable to understand this code, also no issues. Okay, it's just a Python code. Okay, we are just writing sample application, but you ensure that you must understand how to write a Docker file, all those things. Okay, that I'll explain while we are doing, so you no need to worry on that. I'll just call this count times. And I'll call this function and I'll provide port as 5000. Okay, this is our app.py. Okay, now let's create requirements.txt file. Our major requirements here is Flask and Redis only, nothing else. Okay, so requirements.txt. Okay, I'll add a Flask and Redis as my dependencies. Okay, now we will write a Docker file. Okay, so vi space Docker file. You already know, right? I have already covered how to write your own Docker file. Okay, if you didn't watch that video, watch. Okay, I'll provide playlist link. Okay, I'll just provide image name. I'll call the image Python. Okay, Python 3.9. I'll just use slim. Okay, to reduce image size, and I'll make work directory dir as /app folder. Okay, and I'll copy the requirements. We are just copying it from our host machine to our container. Requirements.txt. After that we have to run. Okay, I hope you understood, right, what we are doing. First we are from 3.9 hyphen slim, you can see, right, what it means. This sets the base image for our container. Python 3.9 slim is a lightweight version of Python 3.9. Okay, small size. Okay, your container starts from this minimal Python environment. Work dir. Okay, we are setting the working directory inside the container to app folder. Any future commands, okay, copy, run, all these commands will run inside this app folder. This copy requirements.txt, what it is doing, it copies the requirement file from your host machine into containers app directory. Okay, this dot means current directory inside container, okay, which is our slash app. Okay, next we are going to run pip install no catchy hyphen dir hyphen or recommends dot txt. Here, what it means, it installs Python dependencies listed in the recommends.txt inside the container. Here you can see, right, no catchy. Okay, here should hyphen should come. Okay, hyphen no hyphen catchy hyphen dir. It ensures pip does not store catchy. Okay, reduces image size. Okay, that's why I have used it. Next is copy. Okay, we are copying our app.py that we have written, okay, to our image. Okay, what it means, it copies the app.py file from your host into the container, again copied into app folder, okay, which is working directory. Okay, next cmd cmd and I am going to run the command python app.py. Okay, what it means, the default command, the container runs when started. Okay, this launches our Flask app using Python. Okay, whenever container starts, it will run this command to start our application. Okay, in short, what we are doing, with the help of we are choosing a base environment. With the help of work here, we are setting the working directory. With the help of copy, we are just like adding project files into container. Okay, with the help of run, we are installing dependencies. Okay, again we are copying, again we are doing cmd for to run the application. Okay, let me save this. Okay, now let's write docker compose.yaml. Okay, it is an YAML file. Okay, YAML is it's not a programming language. Okay, YAML is a data format like XML and JSON. Okay, which is like a normal English. Okay, now we are going to write this YAML file. Okay, version I'll just provide as 3.9. Did you know what this 3.9 indicates? This specifies which version of Docker Compose file format you are using. Here I have provided 3.9, which supports latest syntax and features. Okay, so I have provided 3.9. Okay, services. Okay, services. Now here we are going to use web and Redis services. Okay, web. Okay, here this services, what it is doing, it defines all containers your application need. Okay, first one is service, one is web. Okay, which is our Flask app. Okay, web, we are going to build it, build container name, I'll just name my container as Flask app. Okay, the thing is, here what we are doing, dot build, what it will do, it will build the Docker image from the Docker file in the current folder. We have created our Docker file, right, that we are running with the help of Docker Compose. Okay, with the help of this build. Okay, next is container name Flask app. Okay, it gives a custom easy to read name for our container. Okay, next is port. Okay, ports 5000, host port is 5000, container port also I am giving as 5000. So what it will do, it maps host port 5000 to container port 5000, so we can access our Flask app at 5000 port. Okay, next is depends on. Okay, where it depends on Redis, right? So we have to write it depends on Redis. Okay, so here what it will do, the web service waits for the Redis service to start, because we are adding this as a dependency. Okay, it ensures Redis container comes up before Flask app starts. Okay, now we are going to write another service. okay, because this is multi-container app, right? So we are going to write another service now, which is Redis. Redis, okay, image Redis Alpine. Okay, I am using image as Alpine. Okay, so the thing is, here what we are doing, any idea what we are doing here? Here we are putting official Redis lightweight image Alpine, okay, small size Linux distribution, okay. After that, what we are going to do, we are just going to write our container name again, because we have to create container name for this also, right? Container underscore name Redis catchy. I'll name this as a Redis catchy. Previously, our Flask, our web app name is Flask app, container name is Flask app. Our Redis container name is Redis catchy. Okay, and ports hyphen 6379 colon 6379. Okay, so this is what it indicates. It maps the Redis default port. Okay, you can connect to Redis using localhost 6379 if needed. Okay, here what we are doing version, which is compose file format service. We are defining multiple service. One is our web app, another one is Redis. Okay, here purpose of web app is it's a Flask app container. Okay, this is our main application, and Redis, this is a Redis catchy container, and depends on we are adding as a Redis. Okay, it will start, it is a start order. Okay, so it will ensure that Redis container is up and running. And ports, why we are using ports? To expose our container ports. Okay, so the eye level flow of this app should be, so user, okay, when user types http localhost 5000, it will go to Flask app. Okay, if you do this in browser, it will go to Flask app go from Flask app to Redis catchy. So it returns the page it count, because it is the one catching it, right? Page it count. Okay, so this is how it works. Okay, since here I am using AWS VM. Okay, so you must allow 5000 port and our Redis port. What is our Redis port? We haven't saved still. Okay, so Redis port is 6379. You have to allow this in your security group. Okay, I have already did it. Okay, if you are not doing it, it will not work. So just enable it. Okay, just enable it and provide. Okay, once you save that. Okay, now let me save this. Okay, now I have saved it, right? So you can see I have all my files. Okay, what's next? Now you know how to write a Docker file, how to write a Docker compose. Okay, and you understood the high level flow of this application. Now we have to build, right, how to run this project. First we have to you don't need to run separately, you don't need to run your Docker file. Just doing Docker compose up is enough, right? So let's do that. So Docker -compose -d for detached mode, it will run in the backend. Up -build. What issue we are getting? Here there is an issue. Are you able to identify what is the issue here? Are you able to get? If you get that, if you are able to understand what was the issue, just let me know on the comment section. Okay, the correct command is, it should be Docker compose up Okay, after that only you have to provide -d. Okay, so up what it will do, it starts the container -d, it runs in the detached mode. Build is it force rebuild. Okay, so you should not use -d, -d should not come before up. Okay, so the syntax is docker compose options and command. Okay, because -d is not a global option. Okay, it's not a valid global option, it's an option for up command. Okay, so we have to run like this only. And if you want to see logs, then you can avoid -d also. Okay, so let's run without -d so we can check, okay, all the logs. Okay, just to explain this, I used -d there. Okay, there was an build error, you can see at line number Dockerfile line number 11. What was the issue? Are you able to understand what is the issue? You can see if I use cat and if I use docker, if I open Dockerfile, you can see this. Here there should be a space. Okay, I haven't used this space, so only we are getting this issue. Let me provide this space. Okay, now I'll run again. Again we are getting an issue. Copied requirements. Here you can see what this indicates. Any idea? You can see it is failing on our requirements file, right? Error. While copying requirements, we are getting an issue. What was the issue and how to fix? The reason for making mistakes here is I want you to know debugging also. Okay, actually spelling is wrong. We misspelled the name. You can see here. I have used RE. Okay, it should RE. Okay, I missed E here, so we are getting this issue. Okay, so I'll update it. Okay, in real time this and all issues you may get. Okay, so that's why I made some issues just to explain this kind of things. Okay, now again we will run. Again we are getting an issue. Why we are getting this issue? We fixed it, right? Even you can see here is same name, but why we are getting this issue? Any idea? Even it has been updated, right? But here you can see again, here I haven't updated, so I have to update here also. Okay, it is installing all the dependencies. Okay, now our application is running. Okay, this is our application logs. Okay, so I'll just can abort this. If I do docker ps, I can't see anything because I am not running this in the backend. Okay, if you do control C, it will come out of this. Okay, so only it came out. Okay, so again if I want to run, what I can do this time, I just to show the logs I just did this. Okay, I will use -d now. Okay, we will run it in the backend and we can check logs with the help of docker logs command. Okay, we are getting some issues. If I do docker ps, our image is running, like our container is running, but only our Redis container is running. If I do docker images, you can see the two image, multi-container web app image as well as this. I'll just type both and I'll recreate. Okay, so docker orm -f docker ormi because previously we executed, right? That's why we are getting some issues. Okay, I'll just delete all these things. Okay, now we will run this image again. Again it is creating from the scratch, you can see. Now we are getting an error. What was the error? Here you can see. I'll just go with continue. Okay, I'll just continue. Okay, now we are getting some more error, you can see. Are you able to understand what is the issue here? Redis is up to date. Okay, it is recreating the Flask app, you can see. While recreating Flask app, we are getting error. Are you able to understand what is the error? Let me show you. Container config error we are getting. How to fix this? Because in real time you will get this kind of issues. Okay, just writing a Docker compose file, okay, anyone can write, but you should have capable to fix this. The thing is, the problem is here a broken old container exists. Okay, Docker compose try to reuse it, but its image was deleted because we deleted it. Okay, compose was crashes. This is a very common Docker compose issue when the old container was created using corrupted image, because previously we got some image issue, right? The SSA image was deleted by our last build. We deleted it manually. Okay, so compose tries to read that metadata, so since it's missing, we are getting these issues. So how to fix this? You can use compose. You can stop and remove all containers from this project. How you can do that? By using Docker compose down hyphen remove hyphen orpans. Now we have deleted everything. Okay, so if I type docker ps, I don't have anything. Hyphen a, I don't have anything. Docker images, I have images, so I'll destroy the images also. Okay, docker image run hyphen a hyphen f. Okay, I just reclaimed 33 MB. Okay, by deleting everything. Okay, so now let's rebuild it. Okay, so this is how you have to debug, and this is how you have to fix the issues. Okay, now we compose, what it will do, it will build a fresh image and it creates a clean containers, avoid using broken metadata. Now you can see perfectly it was done without any issues. Okay, so this is how in real time you have to handle. Okay, so docker compose ps, you can see both containers. Okay, one is our Flask app and another one is Redis. Okay, now how I can test this? Any idea how I can test this? If I want to run this application, then how I can run this? Any idea? Since I am running this this in AWS VM, how to run this application? If you know, just let me know in the comment section. Just pause the video and let me know in the comment section. Okay, let me open the browser. You can just use your virtual machine IP address, okay, with 5000 port. Okay, so I'll just open one tab. Okay, my IP address is 65.2.127.106.5000. Okay, okay, actually it's wrong. We should type HTTP, not HTTP. 65.2 dot, even you can add this in your resume. Okay, so you can 65.2 dot, if you are fresher you can add it. Okay, so they know that you did something. Okay, 5000, because we are open to port 5000. You can see, actually I already iterated this one time, so it is showing 2. Okay, if I reload it, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You can see whenever I reload it counts. How it counts? Because of our redis only. Even if I'll just copy this and I'll close this. If I open, it will start from where we left. You can see you hit 25 times. Okay, this is how you have to build. You can run multiple service with the help of Docker Compose. Okay, now we can check the logs. Docker logs. I hope you understood how to work with Docker Compose with multi-container app, right? If you have any doubts, let me know on the comment section. You can see this is for our Flask app, and for Redis. Okay, this is Redis log. Okay, our app is working perfectly. So it is storing the cache, right? So the it counter is stored inside Redis container. Okay, proving multi-container communication works perfectly. Okay, even I am closing this again. I am running this. See, 34. It is storing Redis. Okay, so it is storing the it in the Redis. Okay, so how to manage the application lifecycle? You can use Docker Compose logs. Okay, to view the logs. If you want to restart, then you can use Docker-compose restart. If you want to stop, then you can do Docker-compose stop. If you want to destroy, you can use Docker Compose rm. Okay, let's destroy this. Okay, first Docker Compose stop. Now we are stopping both. You no need to stop one by one here. Okay, with the help of Docker Compose, you can just like that, you can stop all the containers. Okay, so it is stopping. Okay, so it is done. Now we are going to destroy Docker rm, Docker Compose rm. Yeah, it is. I am just going to destroy this. Now I have destroyed it. If I do Docker ps, nothing I have. Docker ps -a, nothing. Okay, so what we learned why Compose is needed, and we built a real Flask plus Redis app. We saw how Compose handles networks and our communication between our web app and Redis, right? We learned to scale services, right? So this is how in real time you will create a Docker Compose file. Okay, if you like this breakdown, subscribe to CloudOps Craft. We will simplify cloud and DevOps concepts every week. Thank you. Hello everyone, welcome back to CloudOps Craft. Today we are going to discuss about securing Docker best practices for image and containers. Okay, Docker makes a deployment incredibly fast. You package an app, ship it anywhere, and it just works. But here is a hidden risk. If your Docker image or container is not secure, you might be deploying a Trojan horse into production. Okay, so the thing is, imagine your servers without security. It's like downloading a random .exe files from the internet, right? You don't really know what's inside. So the thing is, so securing Docker plays a major role. Okay, so securing Docker images. First, how you can secure? Let's go through 4 powerful image level best practices with real hands-on commands. Okay, so first is go with trusted base image. Go with use trusted base image. Trusted base image. Okay, start only from official or verified base images. Never pull from unverified users on Docker Hub. Okay, so and don't use generally like from Ubuntu latest and all. Okay, so it's not that good because you are not it will just install latest version. You don't know whether like it has any bugs. Okay, just go with any version. Okay, like 22.04 or 20.04 or 24. Okay, like for example, you like whenever you pull Ubuntu image, just use Ubuntu 22.04 like that. Okay, just pin the version instead of going with latest. Okay, so use actually why latest changes unexpectedly. Okay, verified images comes with the signed checksums and regular patches. Okay, so only I suggest you to go with verified images. Okay, so the thing is, keep images minimal. Second is keep images minimal. Okay, smaller images equal to fewer vulnerabilities. Okay, avoid full OS images unless necessary. Use slim or alpine variants. Okay, so you can just go with the doc instead of using docker pull python 3.12, go with docker pull python 3.12 slim whenever possible. Okay, but you don't want but in your case, if you are not like you can't use slim, then only you can go with major version. Okay, if it's possible, try to go with slim or alpine variant. Okay, so you will see the slim version is around 150 MB only, but actual version it will be around 900 MB. Okay, so it reduces the attack surface. Okay, third third thing is third best practices, don't hard code secrets. Okay, don't hard code these secrets. Okay, so never store secrets in your docker file. If you write, for example, if you are writing env and if you are providing password, it's not then anyone can extract it, right? For example, while you are writing docker file, you are providing env db password equal to super secret 123. If I am providing like this, then anyone can extract it. Okay, so with the help of docker history. Okay, don't do that. Okay, you literally see your secret in the image history. The better approach is use runtime environmental variables or docker secrets, especially if you are working with the compose or docker swarm. Okay, so how you can pause in runtime environmental variables, you can use like docker run. While running, you can provide use -e, okay, and provide this password here. Okay, so it will be better instead of adding this env in your docker file. Okay, next best practice is scan images regularly. Scan the images that you are using regularly. Scan images regularly. Before deploying any image, scan it for known vulnerabilities. Okay, you can go with the docker scan, or you can use trivi. Okay, or you can use any other scanning tool. Okay, you can for example, if you are choosing to work with trivi, then just set up trivi and test the images. Okay, I think I have installation steps for trivi. Just give me a minute, I'll check. Okay, let's set up Trivi on our AWS VM, and we will check how to test with Trivi. Okay, so scanning is must. Okay, scan images regularly before deploying any image. Okay, so we can know the known vulnerabilities. Okay, if that vulnerabilities affects our application, then we can avoid that image. Okay, so actually this is my repo. Okay, I just added those instructions now. Okay, like how to install trivi on your VM. Okay, so you can use this. I'll provide this repo link in our description also, so you can use this. Okay, so let's copy paste, let's install Trivy. Okay, first we have to update package list. Okay, first we have to update our package list. After that, what we have to do, after that we have to install helper packages. Okay, we have to install helper packages needed for adding http apt repos and managing gbg keys. Okay, so just copy this command and paste it in the server. Next, what we will do is we will fetch Trivy repository gpg public key and convert it to a keyring file. Okay, here is the command. And next is we are going to add the Trivy repository to apt source referencing the signed keyring. Okay, as well as, and we are going to use the current distro code name. Okay, so here you can see. What is the issue? Echo. Okay, added. Okay, so next what we are going to do, again we have to update our package list again, so apt knows about packages in the new repo. Okay, again we are now only we are going to install Trivy from the newly added repository. Unable to locate the package. We are getting this issue. Why we are getting this issue? Let us debug. Okay. Actually, we are getting some issues in this command. Right. So what is the issue? Let's check. Syntax error near unexpected. Actually, this is because of pipe. Okay, it everything should be in the same line. Okay, so let's update this. Okay, okay, now it is fixed. Okay, next, what is the command? So again here also I'll fix it. Okay, everything should be in the same line. Now we will try to install Trivy and we will check. This time it is working. It's because of that command only I have updated it. Okay, so while you are doing, you will not get that issue since we fixed it here. Okay, so now we are going to test the image. Okay, so let's test with nginx image. Okay, sudo trivy trivy image nginx latest. We are scanning this image now. Okay, let's wait, let it scan. Okay, output shows common vulnerabilities and exposures. Okay, if you see high or critical, then don't deploy. Okay, let's wait for the report. Okay, even if you are creating your own image, you can use Trivy to scan that image. Okay, just to ensure that that image has no vulnerabilities. Okay, if you are seeing any critical or high vulnerability, then don't deploy it. Okay, it's not good practice, as well as it is risky. We are using Trivy. You can even use Docker scan, anything you want. Okay, it's up to you. It is installing. Let us wait. Okay, we got the report. Here you can see this is the report summary. Okay, it has 96 vulnerabilities. Here you can see unknown is one, low, medium. You can avoid low, medium. You can check for high and critical. Okay, it doesn't have any critical, but it has 3 I. Okay, so you just check that that 3 points. Okay, it should not affect your application. If that vulnerability is affecting your application, then don't deploy it. You can just, we will check that it's medium. Okay, I, here you can see, you can read about this, okay, by clicking this link. Okay, so you have to read and understand, and you should ensure that it should not affect your application. Here you can see this is second one. One, two, unknown also you can check. Okay, it will be better. So we can able to see only 2 I, but it is showing 3. Maybe somewhere it will be. Okay, so you can check for unknown and I. Okay, critical. Okay, it should not affect your application. This is how you have to scan. Okay, in real time. Okay, whenever you write your own image, or if you're pulling some images from Docker app, just ensure that security level vulnerabilities, so you can avoid unnecessary issues. Okay, next is securing containers. How to secure containers? Now we saw the best practices of how to like work with images, right? So we saw some 4 powerful image level best practices. Now how to secure containers? Okay, first is, to secure containers, go with the least privilege principle. Okay, LPP. Okay, while coming to securing containers, go with LPP, least privilege principle. Okay, so the thing is, by default Docker containers runs as a root. Okay, that's dangerous. If someone breaks out, they get root access on your host. Okay, always add a non-root user in your Docker file. Okay, for example, how you can check whether you are running it in root or not? Just go to your VM, type docker ps. I don't have anything. Docker ps -a. Okay, I don't have any running containers. But how you can check is, you can just type who am I. Okay, so if it is showing as a root, then you are running in a root user. Okay, that is one. Okay, just the command is, I don't have any running container to show that, but it's easy only. Okay, just type docker like exec -it my container who am I. Okay, if it is showing as a root, then you have to fix your Docker file. Okay, it is risky. Okay, so next is second best practice is, go with the capabilities. Limit capabilities. Okay, Linux gives containers many privileges they don't need. You can drop all, then add only what's required. Okay, so if you remove Linux kernel privileges, add only bind services to port permissions. Okay, third one is, use resource limits. Use resource limits. Okay, yeah, single buggy container can eat up all RAM and crash your host. Okay, set CPU and memory limits per container. How you can do that? For example, if you are running docker run command, just do docker run -m for memory 512 m. Okay, CPUs I'll give 1. Okay, it will not eat more than this. Okay, and you can check status using docker stats command. Docker stats command. So you can see live container usage. You will notice memory and CPU capping in action. Okay, without limits one container eats all resources. With limits it's a balanced use. Okay, fourth best practice is read only file system. Okay, if your app does not need to write to disk, then lock the file system. Okay, so you can run like docker run hyphen read only, like that you can lock. This prevents attackers or compromised processes from modifying files. Okay, securing the docker host. Docker security is only as strong as the host it runs on. Okay, checklist is keep docker engine updated, restrict access to the docker socket. Okay, you can, if you do ls hyphen l slash where slash run slash docker socket. Okay, it should be slash, it should be here. You can see only root or docker group should have access. Here you can see only root and docker group has access. Okay, ensure this also, and enable firewall rules. Okay, 22 port 80 all those things. Okay, and check docker logs frequently. Okay, so these are all the best practices you can follow uh, to ensure your app is secure. Okay, if you like this breakdown, subscribe to Cloud Ops Craft. We will simplify cloud and DevOps concepts every week. Thank you.